Yes, it's the 2019 November paper 2 science physics. For those who don't know that paper 2 is science is physics, I'll be answering part 1, section A, only 1 up to 20. So follow me and pay the tutor. Answer all questions on the answer grid provided. Make sure you answer everything on the answer grid provided. Which of the following is an example of an application of chemistry in a home? They don't want anywhere. They only want in a home. A, the use of amplifiers in radio chemistry. B, the use of cosmetics, production of ammonia in herbal process. Can you do that in a home? No. Industrial production of alcohol. They haven't said industrial, not home production of alcohol. So the answer is the use of cosmetics. Who doesn't use cosmetics in the house? Okay, then we go to 2. The best apparatus. The best apparatus that is used accurately to measure a required fixed volume of a reagent during titration is. Now look at this. You have a beaker here. You have a pipette, a cylinder, and a burette. Which one is the most accurate among these? The answer is B. It has got exactly 25 cubic centimeters of volume. That's very accurate. So this is what we call a bulb pipette. The best method to separate a mixture of sand and diesel is filtration. Whenever you have sand and diesel is acting as a what? As a liquid, and sand as what? As an insoluble solute, as an insoluble substance. So you use filtration. 4. Identify an inert gas from the diagram below. Which one is an inert gas? Inert gas, they are those gases in group A, also known as noble gases or group O elements. Which one from here? Now when look at here, a gas has got the same particles are the same, and in the here all what they wanted to confuse you is the inert. Forget about the inert. Gases, the particles are the same and they're far apart from each other. So the answer is C. So here all what they wanted is to confuse you on the inert. Your main concentration was supposed to be on a gas. The following equation is incomplete. What is X? Now this is a lithium hydroxide react with sulfuric acid. This is an hydroxide. So what we are going to have here is a salt and water. So we are going to have lithium sulfate plus water. So this is what we need, the lithium sulfate plus water. Now, is it balanced? When you look at here, you have 2 lithium and here you have 2 lithium. We have 4 hydrogen this side. Do we have 4 hydrogen here? No. So we need to put a 2 in front here. So what we have here is this and this, which is A. So the answer is A. Question 6. Which of the following molecules have a triple bond? Which one has a triple bond? Now these, they are going to bring you oxygen has double bonds. Chlorine has a single bond. Carbon dioxide, it's a combination of that. Then something like that, if I'm not mistaken. Then you have nitrogen. Nitrogen is a combination of 3 double bonds. Triple bond. So the answer is nitrogen here. The equation below shows the preparation of a salt. Silver nitrate plus sodium chloride giving silver chloride and the sodium nitrate. Which of the following gives the correct description of the equation above? The salt which is being formed is this. Correct? The type of the salt. So against that, the salt which is formed is this one. So this one and this one. So these two are out. And that's how you answer multiple choice. Type of salt, is it soluble or insoluble? Silver is insoluble, it's an insoluble salt. And it's filtration. The answer is A. Method of separation, you can separate an insoluble salt by crystallization. No, it's by filtration. Simple as that. So the answer is A. What mass of copper oxide would react completely with 500 cubic centimeter of 0.5 dilute sulfuric acid? Okay, now here what we need is to calculate the mass of copper to oxide that would react with the 5 cubic centimeters of dilute sulfuric acid. First, we have concentration here. We know that concentration is equal to mole over what? Over volume. Okay. Concentration here is 0.5, which is equal to the number of moles we don't know. Let's find the number of moles. Volume here is 500. Now we need to convert this 500 into decimeter what? Into decimeter cubed. We know that 1 decimeter cubed has got 1000 cubic what? Centimeters. So that would be 500 divided by 1000. That will give us 0.5 here. So to find x is equal to 0.5 times 0.5. That will give us 0.25 moles. Now these are the number of moles that we have. Now, step 1. Step 2, mass is equal to molar mass times the number of moles. Okay. So the molar mass for copper to oxide. Now copper to oxide is like this. Okay, that's copper to oxide, and copper here is 64 plus oxygen here is 16. So when we look at 64 plus 16, we are getting 80 grams per mole. So we are saying 80 times 0.25. That will give you 20 grams. And the answer becomes D. So this is more concept. So they gave you this information so that they can just find the number of moles. Then use this molar mass, and mole equation to find the mass. Don't feel scared. The table below shows some transition elements and their uses. Which one is the correct? Which one is the correct use in the contact and Haber process? Now, contact catalyst used in the contact process is what we call vanadium. Others, they say no, vanadium pentoxide. It's okay. But we are talking about the element itself involved as a catalyst is vanadium. Catalyst in the Haber process, it's actually iron. So that is the answer. Which of the arrangement below is suitable for collecting a soluble gas that is denser than air? Now, something which is denser than air, you need your jar should be like this, so that even if a tube comes like this, the gas will still go down, and air will be where? Air will be on top, but your gas will be down here. That's what you must know. Then, if the gas is soluble, you can't pass it through water because it's going to dissolve in water. Even this one is going to dissolve. A could have been correct, but the position of the gas jar is not correct. So we go for C. Calcium oxide is a drying agent that can easily dry the gas which is soluble, and it becomes denser there, so that the jar, which is put in perfect position there, can collect the gas. The reactive formula mass of calcium hydrogen carbonate is, now we have calcium. Now do this. We have, remember this 2 here means is multiplying everything. We have 2 hydrogen, we have 2 carbon, 2 times 3 here, we have 6 oxygen. So we need to find the mass. Calcium has got a mass of 40. Hydrogen is, it's 1. Now 1 times 2 give you 2. Carbon, you know that carbon is 12, right? Now 12 times 2 give you 24. Oxygen is what? 16. 16 times 6. So 16 times 6 will give you 96. Like that. Now we need to add those. Plus 24, plus 2, plus 40, and see if it's giving us anything like that. And it's true, we found our answer to be 162. Which of the following statement explains why magnesium, calcium, and barium are placed in group 2 of the periodic table? Why are they placed in group 2 of the periodic table? Is it because they have 2 electrons in the outer shell? Or is it because they are basic oxide that are sorbing water? Or maybe the outermost shell are lost, or electrons are lost when they react with nanometals? Or is it because they form positive charged ions? All metals, they form positive charged ions. That can't be answer. Their outermost electrons are lost when they react with nanometals. That can occur for any metal, not only group 2. They form basic oxide that are soluble in water? No, really. The reason why they are placed there is A, because they have 2 electrons in the outer shell. And the number of electrons in the outer shell, it determines the group in which that element is going to be put. Let me give an example. Magnesium, which has got 24 here, it has got 12 here. When we look at the atomic number is 12. The electronic configuration is 2, 8, 2. So you can add here, give you 12. This shows that the last shell has got 2 electrons, and that's the group 2. It is 1, 2, 3. The number of shells, it determines the period. So it's in period 3. Hope you get that correct. How many molecules are found in 6.0 decimeter cubic of carbon dioxide at RTP? Now, at RTP, we know that the volume of N gas is 24 decimeter what? Cubed. It's 24 decimeter what? Cubed. So let's find the number of moles. Number of moles is equal to volume given over volume at RTP. The volume given here is 6.0. The volume as at RTP is 24. We're saying 6 divided by 24, that will give us 0.25. These are the number of moles that we found, 0.25. That's how we find the number of moles in terms of volume, by the way. Then we know that 1 mole of N gas, as long as any mole of any gas contains 6.02 times 10 to the power 23 molecules. What we have here is 0.2 moles. So what we have here is 0.2 now moles. This is what we must. This is what we call the Avogadro's constant, a number, or the Avogadro's law, which says that one mole of any gas contains 6.02 times 10 to the power 23 molecules, ions, or atoms, or particles. Now, what we just found that there is 0.25 carbon dioxide moles at RTP. How many particles or molecules is it going to have? Or yes. So then we multiply it by 6.02 times 10 to the power 23. That will give us 1.505 times 10 to the power 23 molecules. Now when we look at this, 1.5, that's the same as here, times 10 to the power 23. So guys, chemistry is simple. Okay, chemistry is really simple. You know these things. Which of the following is an alloy? Now, let me tell you a secret when it comes to chemistry. Once you forget what that word means, you are gone. So, for example, when they say, what is an alloy? If you don't know what an alloy is, you are likely to black out on your answer. An alloy is a combination of two or more metals. And the examples of alloys, it's bronze, brass. These are the most common ones. C. Oh, here it's supposed to be A. Halogens are useful elements but also cause harm to the environment. Which of the following is a true danger of halogens? A. They cause HIV and AIDS in human beings? Not really. They deplete the ozone layer. Are used to treat wounds. They all release harmful radiation in the environment. They deplete the ozone layer. That's the most effect they cause. The best way of preventing spanners, pliers, and screwdrivers from rusting is, so here, it doesn't matter. Or what they're talking about here, they are all metals. If it can be a spanner, a pliers, or a screwdriver, they are all metals. How can you prevent a metal from rusting? In short, is it sacrificial protection? Is it tiling? Is it oiling or galvanizing? In case of these metals, we use what we call oiling is the best, not really galvanizing. No. Sacrificial protection. This thing has already been made, by the way. So how can you protect? A spanner has been made already. How can you protect it? You oil it. The gas that combines with hemoglobin and reduce its capacity to carry oxygen in the body is it nitrogen dioxide? Is it nitrogen monoxide? Nitrogen dioxide is like this. The nitrogen oxide is like this. Is it carbon? Is it carbon dioxide or carbon monoxide? So the answer is carbon monoxide. Which of the following substances is not a synthetic fiber? Which one is not a synthetic fiber? Anything which is synthetic, that means it's man-made. Now, which one is not? Nylon. Nylon is a synthetic. Cotton. Cotton is it? Is cotton a synthetic? Polyethylene is a synthetic. Polyester, all these are synthetic. The only thing which is natural here is cotton. 19, but not the least, the compound represented below is which one? Is it ethene, ethine, ethane, or ethanol? It has double bond. This is a double bond because there are 4 electrons, so we have a double bond. Carbon and carbon. Hydrogen, 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 hydrogen. What is this? Ethene. It's an alkane, an alkene. Ethene is an alkene. What is the name of the compound below? What's the name of this compound? Can you guess the name of the compound? If you can guess, hit the button, pause the video, and try to answer on your own before I answer it. All right, so before I give you my answer, look at this. Look at this here. There's a double bond, and there's another oxygen. This means there was a reaction between 2 compounds. We don't know. So in this case, we had reacted an alcohol plus an acid to give us an ester. This is an ester. Now, where did we get the how is the name going to come? This part here comes from an alcohol. This part here comes from an acid. Okay, so this part here is an ethanol. You can see. So this is ethanol. So ethanol. Then this is ethanoic acid. So we have ethanoic acid reacting with the ethanol. So this will be ethyl ethanoate. Is 2021 previous day tutor. Please subscribe to my YouTube channel. My students, please make sure you study hard. All right, paper 1 is tricky, especially 1 to 20. If you forget any word, so make sure you know what each and every word means. I'm out. All the best.